Okay, measures of central tendency. So there's a few simple ways to describe data, descriptive statistics. The first is measures of central tendency. This should be extremely familiar to you by this point in your life, so we'll go through it quickly. Mean, median, and mode. Each one is computed differently, and they're used in different situations. The mean is by far the most common in quantitative research. It's normally dealing with continuous data. You'll find out about what that is later on in the lab. So when an article says the average, it's almost always referring to the mean. So when someone says, what is the average age when kids get their driver's license? Or what is the average number of firearms owned by the American household? We're talking about the mean in most cases. Typically, if we're talking about the median or the mode, they'll actually say that. But average is used almost interchangeably with the term mean, although it's not technically right. To get the mean, you add up all the numbers and divide by the number of numbers. So if we wanted the average, or the mean, I should say, of 3, 5, 2, 6, and 4, we would add up 3, 5, 2, 6, and 4, which would give us 20. We divide by n, or the number of numbers. In this case, it's 5. 1, 2, 3, 4, 5. So 20 divided by 5 is 4. The mean of the distribution is 4. Okay. So this should be familiar. If this is news to you, then maybe just look at this a couple times and then it'll be familiar to you too. So you could try this also if you wanted to pause the video and work it out real fast on the Windows calculator. But to do that, you would add up all the numbers. 1, 2, 3, 4, 5, 6. So that would give you 42. There's 6 different numbers. 1, 2, 3, 4, 5, 6. So 42 divided by 6 would be 7. So the mean is 7. Two downsides of the mean. So it is the most common, but a couple of disadvantages. One is it only works with certain kinds of data, interval and ratio level data. So I think it was in the reading, and we'll also see in the lab, there's different kinds of data, nominal, ordinal, interval, and ratio, and this only works with some of them. Also, the mean is not robust to outliers or extreme observations. So robust basically means it works just fine even when that's going on. So if you have some, I think earlier we gave the example of you have the ages of kids in a kindergarten class, and maybe there's a mistake and someone accidentally put 65 instead of 6, and then another kid is 5. If you did that, it's going to way throw off the mean. It's going to really skew your results. You'll have a number that misrepresents that distribution. So some data, the mean won't work. If you're interested in preferred sports, so what's you have a group of kids or a group of college athletes, and you want to know what's their favorite sport, the average sport that they prefer. Um, it's soccer, so there's 5 people. I like soccer. I like baseball. I like soccer, football, baseball. So 5 people. You couldn't really find the mean because you'd have to add these up and divide by 5. Soccer plus baseball plus soccer plus football plus baseball divided by 5. That doesn't make any sense at all, right? So that's no good. Can't use it. And then what about when you use extreme values or have extreme values? So let's say we're looking at kids in a junior college course um, at, I don't know, RCC or something, and most of them it's maybe a daytime class, so there's a lot of younger people in there. So maybe there's 5 of them. There's 21, 19, 18, and 20, and then there's a 72-year-old. Maybe it's not a mistake. Maybe somebody really wanted to go back and finish their education, or they're a lifelong learner, or whatever reason they're in there. Well, that's going to really impact the mean. So if we were to find the average, we'd add all these up. 21 plus 19, blah, blah, blah. That would give us 150, would be the sum. We divide by the number of observations, which is 5. The average is 30. That's the mean. So if we look at this class and say, oh yeah, the average student in that class is 30. So maybe you're the professor and people are asking, oh, how old are the students in your class? The average is 30. That really doesn't seem like a good way to describe these students, does it? Right? It doesn't make it because no one's really anywhere near 30. Someone 21 or 19 to 30, those are very different life stages. I mean, this person's probably living at home. This person's in a dorm or a college, junior college, not a dorm, but maybe living with friends or something. And then a 30-year-old has a wife and kids possibly, and then a 72-year-old, that's nothing compared to 30. They're very different. So describing this is the average student is 30 just completely misrepresents the group. That's no good at all. So a way to work around that is to use the median. instead of the mean. So median just means the middle value. You line up all the numbers in order, lowest to highest. You go to the very middle, and that one is the middle, the median. And if there's two in the middle, because there's an even number, you just divide those, get the mean of those, and then that becomes your median. So in this case, we put them in order, 18, 19, 20, 21, 72, right? Lowest to highest. We find the middle value, which is 20. The median is 20, right? So wouldn't that seem like a better way to describe the students if you ask the professor, oh, how old are the students in your class? Oh, on average, they're like 20. Oh, okay, 18, that's about right. And then you get this person who's an outlier, but they're not really the average student, are they? The average student is about 20. So that makes a lot more sense. So if you want to try this on your own, if you want to find the median IQ score from the students in a special education class, right? So you'd line them all up in the right order. 75. So this person is quite a bit slower, and this person is more on the gifted side. You go to the very middle. There's an even number, so you have to take the mean of these two, which would be 83. So the average student or the median student is 83. And again, it's a pretty decent way to describe these data. This person, maybe they're in special education because they have an emotional disturbance, and it's not because they have any kind of a cognitive deficit. So they're in there for some other reason, but they're really not the average student. Right? So this represents us much better, 83. Okay. The mode. This is what you use when you're using nominal level data, and I can talk about levels of measurement a bit with in the lab, I believe. So nominal levels is just categories, and we're looking for the value that occurs the most often in the data set. So when you think of mode, think most. M-O-M-O. Mode is most. So back to our sports example: soccer, baseball, football, baseball. We could find the mode of these data. So soccer occurs twice. Soccer, soccer. Baseball 3 times, baseball, baseball, baseball. Football occurs once, so the value that occurs the most frequently, which is the mode, is baseball. So on average, what sport do these students like? Baseball. Right? So it's the best we have to reflect what we have there. So central tendency is one way to describe data. The other way to describe data, the other central characteristic we're interested in is variability. Basically, it's how spread out the numbers are around the mean. So you have, and now again, we're talking about mean. So we're dealing with interval or ratio level data, and we are interested in how spread out the numbers around the mean. Are they very tightly compact around the mean, or are they all over the place? If they're all over the place, we'd say that there is high variability. And if they're all close to the same, then we'd say there's little variability. So low variability. So the distribution of ages in a 9th grade English class. I used to teach 10th grade English at one point. So you can just add 1 to all these and have the same kind of scenario. 14, 14, 14, 15, 14, 14, 15, 14, 16, 14, 14, 14. There's very little variability, is there? They're almost all 14, and there's a couple 15-year-olds and maybe this kid that's a junior or something that's having to take the class over, something like that. They failed it the first time maybe. But there's very little variability. But in contrast, if you were to look at the distribution of ages of ops students, wow, there's all kinds of people that are in ops here at Cal Baptist. Some of them are traditional students. Maybe there's a 19-year-old or a 21-year-old. But there could be someone who's a little later in life. Maybe somebody's 55 and they really want to go back and do their degree because they want to change careers or enrich themselves in some way. So there's all kinds of people in ops. A lot more variability, isn't there? Very little, a lot of variability. And we want to be able to describe how spread out the values are. That is, how much variation there is. And there's a few different ways to do that. The most well, the most common is actually this one, but the easiest is the range, and then the standard deviation is the most popular, and then the variance, which really is the same thing as standard deviation. It's just displayed slightly differently. Or they're a function of one another, I should say. Most of the time, you're going to find articles reporting the mean and the standard deviation. So they might quickly go through the descriptive statistics, even if it's they want to make inferences. They'll say, oh, well, here is the average value on these 6 different measures. Here's the average for males. Here's the average for females. And chances are you're going to get mean, standard deviation, mean, standard deviation, mean, standard deviation, just listed real quickly there. Or there might be a table with that information. You may or may not see the range, probably not, and you may or may not see the variance. Again, these really are the same thing. They're a function of one another. So you don't actually need both. You have the same. Really, the standard deviation is just a standardized standardization of the variance. So the range, you just find the highest number and the lowest number, and you subtract them, and that will give you the range. So in the op students here, the oldest person in the class was 55. The youngest person was 19. So you take 55 minus 19, it's 36. So there's a range of 36 in the class. So this is again a measure of variability. How spread out are the numbers? Well, the ages are spread out by 36 years. There's a lot of different people with a lot of different life experiences in the same class. It's helpful because it can help you find errors in the class. So if you were looking at kindergarten students and it said the range was 36, that would let you know something's wrong because there shouldn't be that much variation in kindergarten unless you counted the teacher by accident, and then that's your mistake. You figured out what went wrong. Um, Another example would be maybe you collect data on GPAs of college students, and it says the range was 38.2. Well, the GPAs are based on a 4-point scale, so it's not tenable. Tenable just means it's not realistic. It's not feasible. So maybe instead of putting 4.0, somebody put 4.0. They just typed it in wrong, and now we got this ridiculous range. Because we looked at the descriptive statistics, we found the mistake, and we can fix it before we go on, and all the rest of the analysis is screwed up. Okay, standard deviation. So this is the most popular and probably the most important measure of variability. I'm going to walk through the exact process of how to work out this formula in a different video, so I won't go through all this here. But basically, S stands for standard deviation. Sometimes you'll see SD, square root. This is the sum, means to sum up. It's a sigma in Greek. Everything that's over here. This is each observation minus the mean squared over the sample size minus 1. So I've got a few slides so you can take a look at how to kind of work that out, but we'll do that. I'll do that in a separate video. Okay. Hope this was helpful, and we'll look forward to catching you in the next video.